Hi guys. So this week we are going to talk about seeds and germination. Last week we talked about fruit and how those were made and how they helped seeds disperse. So now we're talking about once the seeds disperse, where do they end up and what happens? So let's start by talking about the actual makeup of a seed. So a seed is going to have everything that a plant needs to grow into, or everything that's needed to grow into a plant. Okay, so it's all in there in that tiny little seed. Everything it needs before it can get leaves to start making food. All right, so it's made up of three main parts. First one is the embryo. That would be the baby plant. Okay, and in this picture, the embryo, let me get a highlighter and highlight it, would be this circled area right here. So this is all the baby plants, okay? And after the embryo, you have an endosperm. The endosperm is like the rest of the seed. So like when you eat a pea or a lima bean, it's like the meat that you're eating. Does that make sense? And what that is a built-in food supply for the plant. Before it actually has its leaves to grow, it's going to use the endosperm to make food. And then lastly, the seed coat. And the seed coat is just the hard outsides that are going to protect the plant from disease or insects, or just protect that seed from getting hurt. Next would be germination. So germination is going to be the process of taking a tiny little seed and making it grow into a plant. Okay, so a seed in itself is dormant until you have something that happens that triggers germination to occur. Germination is when we actually start growing. So there's things that are required for germination to happen. So for your seed to start growing into a plant, you need water. And like immediately, that's the first thing that nothing can happen until you have this. You need water to get through the seed coat somehow. Sometimes we soak seeds in water and that makes them germinate faster. Sometimes just the water from the ground will make them germinate. You need oxygen, so you can't have the seeds packed too tightly in soil. There needs to be some oxygen that gets through, and it needs a favorable temperature. The favorable temperature will vary depending on the seeds that you're planting. Like cucumbers require it to be warmer. Zucchini do too. I have a really hard time getting those growing in the greenhouse in the winter. I don't know. And then some have lighting requirements. So some seeds want it light to be able to germinate. Other seeds need it dark. So some like need to be covered with soil and others don't want to be covered with soil. It just depends on the seed that you're trying to grow. Dormancy is going to be the state that the seed is in for the most part. Okay, this is when a seed is waiting to grow. It's considered dormant. Now, some seeds just need water to break dormancy. Other seeds have really specific requirements. All right, so the first type of requirement would be scarification. All right, so think of what a scar is. When you get hurt, a cut, or something like that, you end up with a scar. Same kind of deal here. Okay, a scar is when the seed coat gets damaged somehow. Okay, most of the time, this is done by, I have a cat. This is done by it going through the gut of an animal. So when it like goes into an animal's stomach and sits there, the stomach acid and everything else are going to cause some damage on the seed coat. When the seed coat's damaged, water can then get in, which is our first step in germination. All right. Other times it's done by heat or just by bugs. You can do it. This picture is showing somebody doing it with a knife. You can do it with a knife or a scissors if you have a seed that needs to be scarified before it will grow. Right. The second type is going to be stratification, and stratification is a little different. So plants that require stratification are plants that let their seeds go in the fall, right? And then the seeds sit on the ground all winter, right? That cold winter where you're going to have like things freezing and melting and freezing and melting and freezing and melting, right? When water freezes, liquid freezes, it expands. When that happens, that expansion and retraction over and over again, it causes the seed coat to actually crack, which then in the spring, when you have all the rain, it allows the water to get into the seed so that then germination can occur. All right, so really you have to store the seeds somewhere between 32 degrees and 50 degrees to cause them to come out of dormancy. People do this in fridges sometimes. You can put them in your freezer and then take them out, put them in the freezer and take them out to kind of trigger germination to occur, to have that stratification process occurring unnaturally. All right, but for the most part, these are going to be seeds that have to sit outside through the winter. Steps of germination. So for germination, or when germination occurs, it occurs in a really specific timeline. And if you remember to come get germination tubes, you probably have these and you can see this happening for real. All right, so what happens, the first thing is that a radicle is going to emerge from the seed. The radical would be, let me highlight again. I want to highlight a different color. I can't really see. Let's do red right here. Okay, that's the radical. The radical is going to become the root. All right, so the radical emerges and it grows downwards with gravity. So radical grows with gravity. It's going to go down. All right, and it becomes the root. No matter how you have the seed positioned, the radical will always go down. Okay. And then from the radical, you'll have your root hairs, your lateral roots, and the rest of your root system, which is shown like in these pictures. Those will develop. So radical, I want you to think of the R for radical and think of root. Okay. The next thing that happens once your radical grows is you have a hypocotyl. Let's do that in orange. So that's this guy, right? And think of the H, and I want you to think high. It's going to grow against gravity, so it grows up in response to the light. So the hypocotyl is going to grow towards the light and against gravity. This becomes the first, oh, I don't want that yet. This becomes the first stem-like structure. Okay, and as it thickens, it gets stronger, it's going to become a stem. So that's the hypocotyl. And then the last one, or the last part of like germination, is the cotyledons, which are these here. Okay, they're in that picture right there. And what they are, when you look at the seed, they are on either side of the seed. And cotyledons are what holds the embryo. Okay, and they look like leaves, but they're a little off. So if you get those bean plants that I gave you to germinate, okay, when those grow up, you'll see the first two things to open are your cotyledons. And then between them, you actually have the first true leaves coming, okay, the stem and the first true leaves. But the cotyledons are going to be the first thing. And when the cotyledons open, you can then tell if it's a monocot or a dicot, which are two different types of plants. Okay, monocots produce one cotyledon, mono, one. Dicots produce two cotyledons. Okay, so you can tell dicots are going to have two, monocots have one. And this next slide is going to talk about those a little bit. So monocots and dicots. Here's our picture over here, and you can see the monocot has one here, dicot, two cotyledons, and then remember I said baby stems happen, or like the baby plant right there between the cotyledons right there. Okay, so what happens is that in monocots and dicots, these are the two different types of vascular plants. Remember we talked about vascularization of plants, and we talked about xylem and phloem way earlier in the year. All this is coming together now into one big thing. Okay, we're almost through with all these. So monocots only have one cotyledon, so one leaf comes out of the seed. Okay, this is going to be like grasses, corn, grains. Think about when you plant grass, all you have is one little piece that comes out. Think of when you plant a cucumber, if you've ever done that before. It comes out and two seeds grow. Okay, so flowers that are monocots will only have three parts, or multiples of three. 3, 6, 9. Okay, when you count their petals, you can look at them and tell what it looks like. Monocots also have kind of an unorganized vascular system. There's kind of xylem and phloem all over the place. All right, those were, they're kind of more primitive plants. Then you have your dicots. Dicots have two cotyledons. All right, the flower parts are going to be groups of 4 or 5. So when you look at the flower, it's going to have 5 or 10 petals, or 4 or 8, but it won't be in threes. All right, the xylem and the phloem, that vascular tissue is organized where there's one in the center and then around the outsides. And your example is going to be like your fruits and vegetables, beans, cucumbers, tomatoes. Those are all going to be dicots. A lot of flowers are dicots. You can count the petals and see, but just two general types of plants. All right, so that's it for lecture today. We'll do some stuff on monocots and dicots. Make sure you wrote this all down in your notebook. You're going to use it actually quite a lot this week when you answer questions. All right, I'll see you later.